Yes. Mike leads the Melbourne Privacy Red team and is founder and CTO of DroneSec, a firm specializing in drone security, hacking, and threat intel. He's also known as Chef internally, where he once landed a job as a chef in a red team engagement. Well, that sounds like an amazing story. Why are you not talking about that story?
Good question.
All right, Mike, the floor is yours.
Cool. Let me just share my screen. Let me just double check if I'm streaming it here. Can someone share my screen, or can anyone hear me?
We can hear you. So the way to share your screen is looking at the bottom. There's a green share screen button.
Yes, I just had to grab control. All good. We've got it. Thank you so much.
No worries.
Alrighty. We got vision?
Yes, we do.
Awesome. Well, yeah, thank you everyone for hopping on and surviving an entire day of this. Has been awesome. And thank you to Ian and the whole ComfyCon team. This has been, really, really good. It's the first conference I've ever attended where I've seen all the talks without being pulled away by friends. Also, probably the first conference I've watched in my pajamas, but it's just been really good. So, welcome, and I'm going to give you a bit of an intro to drone security. If you saw a similar talk of mine at B-Sides Brisbane, there have been some big updates to this one, so at least there'll be something new for you. So we're just going to kick things off, and just a little bit about me. My name is Mike. As Ian mentioned before, I try and do PrivaSec red things in the areas that I can, but DroneSec is the main focus where we do offensive and defensive drone security operations. I like researching the Wallamai Pine and different things in terms of open source intelligence, and have just a general passion for capture the flag. So that's a bit about me. My foray into drone security really started about 4 years ago when a colleague of mine, Jeff Thomas, was flying a drone around, and then the next minute was hacked into, and the vision streamed straight to the laptop, the controls ported to the WASD keys, and I was like, man, that was simple, and there seems to be a lot of drones going around these days. So there is a huge space of drones at the moment, and one of the reasons why I want to really take you into this is because of the breadth of things you need to understand around drones. So about 2 years ago, in the desert near the Mexican border, FBI agents were actually approaching an area that the cartel had and was using as a forward operating base. And on approach, roughly 500 meters away from when they got to the area, the FBI agents had like 5 or 6 drones doing low swooping passes at them, not just filming them, but also doing passes that would made them kind of get distracted, and the cartel operatives were able to actually escape. So at the time, they were like looking at it like from a new threat perspective, and obviously that vision was streamed to nearby cartel operators as well. Just one of the many kind of uses for drones. But it's not really just a USA problem. We've had a similar type of thing happen in Australia, down here in Melbourne, where we had a cartel or a drug group put up a drone to look for unmarked vehicles and clothed police officers in the area before they actually did had their meetings and things like that. But it's not all bad. In terms of drones, we've seen huge innovations. There's been the use of Uber over in the other side of Mexico to tell people to use less vehicles and instead use Uber Pool because there's so much traffic on the roads. We've seen incredible innovations from drones that drop life-saving floatables into the water for drowning swimmers to the ones that clear rubbish of power lines and things like that. So there's some incredible uses, and that all goes into the control, the security of drones to protect this innovation and allow it to continue to foster. So I'm going to cover some key things, or what I call, the concepts of drone security. At this stage, we're going to look at some of the attack vectors that affect them, what counter drone systems are, some of the threat intelligence that we look at in terms of drones, some forensics, and what we're looking at next. And it's all really important because you might think, what does this have to do with infosec, and so that's where the problem starts. And then you look at all the other concepts around physical and kinetic security and things like that that come in, and then at the end you realize that it comes back to infosec as well. So I really think drones are quite an infosec related problem, and so that's what we're going to be going through. So when it comes down to drone security, there are three core concepts that you should kind of categorize them into. And the first is that protecting friendly drones against attackers or hackers or physical forces. The second is the protection of the systems that support them, manage them, counter those drones. And we'll be talking about UTM systems a lot, which are basically the systems that govern hundreds of drones at the same time. And then, of course, you have protection against rogue or illegal drones. These are the ones who are trying to get into an environment or an area that they shouldn't be, and we're trying to manage that risk in a way. So when we talk about drones, everyone has a different word for them. You can call them UAS, UAV, RPAS, and if you look at them from the perspective of how similar are they, you can buy very different drones for very different costs. Anyone who does FPV racing will know that $600 is probably not an accurate figure. It's probably much more ballooned than that one, but they might have different ranges and battery time levels. They might have different laws that are associated with them, when you can fly them and when you can't. But they're all flying computers in a way, and they're all governed by different communication protocols that are very similar and suffer from very much the same attack vectors. So to do a little bit of a run over and go back over how drones work in a nutshell, I'll cover some of the blueprints around that. So essentially, how does a drone work? Well, the controller tells the drone what to do, and the drone comes back telling the controller things like the video feed and its battery levels and certain critical information that the controller has to know to continue to drive it. And of course, these days you have the controller or the application talking to vendor servers and places that almost like video games, how they have to sing a little ping back to the vendor server to guarantee authority that you own that game. They tell you things like who actually owns this drone and which area is it allowed in, and where it is in the world at that time. So that's how a single kind of drone operates on a normal scale. And in terms of the communication protocols between it, this is where the big companies like DJI actually make their money. This is where the competition comes in. And it's very much on the basis of trying to provide the best bandwidth and video coming back at the best quality while being able to control it at the furthest range and distance. So if you're looking at, for example, one of the latest DJI drones, they use their proprietary software such as OcuSync, which is both hardware and software based, and that can talk to the controller and the drone in different communication protocols, such as frequency hopping or OFDM. And this basically allows it to have a little bit of redundancy. If the video cuts out, the controller is still going to allow you to, with muscle memory, pull that drone back. And if you lose control of the drone, you're going to be able to still see where the video is to go and collect it. And if you want to look at something like universal traffic management systems or urban air mobility systems, which control multiple drones at the same time, that's where you're taking the controller out of the operator's hand, and instead you're putting it into the control of a server or even a web application. And that is talking to the drone. It may be hundreds of kilometers away, it may be very close, in a way that allows it to do automated runs or modeling or things like that, be attached to a battery recharging station and so forth. And it still communicates via, say, 4G or LTE. So that's another important concept which removes the controller, but still has some similar communication protocols as computers. So when you look very carefully at the drone stack or how drones work, you start to realize there are a lot of similarities to computers. All of the devices talk over IP addresses. They talk over common communication protocols. They have internal and external storage. They are quite literally little hovering computers, and a lot more than your typical kind of IoT. Talking on a certain wireless channel, they actually have computer and Linux systems on board. Sometimes they're Android, sometimes they're Linux. And if you look at things like the vendor server there, that is very much becoming a central point for multiple drones, which, if you want to compare them side by side, starts to look a little bit like this. So a single drone where it has a controller and the drone itself operate like a desktop PC. And the moment you add multiple drones that all respond to a central server, you start looking at like an enterprise network. And then we'll move on to the counter drone systems, which are probably get in trouble for saying it, but very much like the antivirus of the computer world back in the start. And we are in a maturing industry. So these are the systems that try and protect and mitigate drones that are not meant to be there. And very much at this point in time, they're at a place where they just try and take down bad drones. Where they're trying to get them is a whitelist approach. So similar to AVG back in the day, where it would just hit your good stuff and your bad stuff and take it all down. That's where they're trying to move on from counter drone systems and make them very much white labeled. And that is where UTM systems and counter drone systems work very much hand in hand. They want to combine them. So your enterprise networks have almost like an antivirus system built in, which may not necessarily be the best thing. So I'm going to go over one or two attack vectors that affect drones today that are very similar to computer issues, and then kind of compare them versus some of the physical and other ones that we see all the time. So when we look at the big bug classes, or the things that really keep the drone and UTM vendors worrying at night, you're talking about access or manipulation to a drone, which can include its, say, vision, the controller or spoofing those controller commands, which results in manipulation of that movement, and of course the data which is stored and transmitted. And this information could be stored in multiple places, cached on the device, cached on the drone, sent to an overseas server outside of your legal jurisdictions, could be stored on S3 buckets somewhere, and so forth. And that information could include telemetry device, personal registration info, pictures and videos of your home, audio recordings, a lot of different things. And DJI, one of the biggest drone manufacturing companies, is one of the only drone companies to have a bug bounty program. And from the start, it was embroiled in a lot of controversy. You can go look up and you'll be able to find it, probably top results at the time. But some of that revolves around, for example, not even being able to share any of the write-ups on submissions that have been triaged and paid out and fixed. So I've been active on the DJI bug bounty program since about 8 months ago, and you cannot talk about anything you find. They're very strict on that. But something quite interesting to look at is the fact that they don't just look at drones themselves. So the first one there that they pay between 5 and 30K for is products, which you could classify as a drone. And they look at things like permanent denial of service, remote unauthorized to the drone, or hijacking of the devices. But they also do take into mind the fact that apps and infrastructure are included in the scope. So that means that all their web applications, their subdomains, their infrastructure, all of that is included in the bounty program, because they are starting to understand the insane chained attack vectors from simple web apps all the way to controlling one or multiple drones. And when we have cities like Singapore and other places that are trying to bring in universal traffic management between airplanes, close proximity pedestrians, and drones all at the same time, then you start to see the worry of these drones being compromised and being able to do things. So they pay up to 30K. That's not something I've achieved on this platform, but they have tried to pay that out before for some big compromises of encryption keys and so forth. But you can read about that online with more time. So to kind of bring it down a level and show what an example attack vector might look like on a Wi-Fi based drone, you can find these still very much in production today for many different brands, including DJI. You could do something like the following. So you assess the air for MAC addresses which belong to a drone as they're sending off that MAC address. You then connect into that Wi-Fi network, depending if you've brute forced it based on default or weak Wi-Fi passwords, or it has known vulnerabilities using something else. Just like a computer system, they have ports and services that are very similar to computers, and most of the time they haven't been gutted. So they have a Linux system on board with something like IP tables. So with a simple drone where you're able to hop onto the system and find the original controller's IP address, you're able to detect that and then block it and instead whitelist your own so that only you have control to that. You then port the vision and the controls to your own system, and from that point, you can then fly away the drone or do whatever you want with it. And it's quite simplistic, and most drones these days that are worth a lot more are based on RF protocols that don't necessarily have the 802.11x or Wi-Fi standards, and so they can be based on different protocols. But this just gives it a bit of a simple guidance as to it. And I do want to, continue to push the fact that some of these security issues we see within drones are super traditional stuff that you would see as basic pen testers. So there's a lot of common security risks which result in compromise of not just the drone itself, but the other servers and other systems. So I'm not going to go through them all, but I do have some specific use cases that I've come across which have had major or significant effects based on common security risks that end up taking an effect on drones. So one of them was this company that was innovating really, really quickly. They got a bunch of seed money and they managed to get the company to a reasonable size very quickly. And there was a huge need for what they were doing. And that was basically focused on providing data analytics for the telemetry of your flights. You could see where you went, you could see your battery levels and so forth. However, just by innovating so quickly and not putting any security architecture in it, because it was drones, not computers, there was a single AWS S3 bucket across multiple actually, but a single bucket which had footage that had been taken by police and that was being used in court cases. There was footage of critical infrastructure like pipelines being videoed and then being stored on there. You could just actually determine who owned the drone itself, the details, and this becomes quite sensitive when you have, say, a police force that is using a certain make and model of drone. If it's just like computer systems, if you know the exact version and software number, you can look up vulnerabilities that are specific to that. So in India, they are using a lot of drones these days for protests and for controlling those protests. So knowing the exact make and model is a bit like disclosing too much, unnecessary information. And so here it was just a simple solution of them not, even putting security architecture in, because they treated it like a drone project rather than a computer or a IT project. We've seen a similar thing with a UTM system that basically allows you to control your whole fleet from a simple web app. And they had a PDF on one of their directories, which basically told you your first login credentials should be vendor and vendor 123. If you just went to the front of their page and saw the different logos of the people they were working with, you could simply use those, and a small number of those managed to be able to log in because they just hadn't reset that password on first login. Now, this might seem extremely simple, but if you think about controlling a whole fleet of drones that belong to someone else, might be carrying payloads, and might be in different remote areas of compared to where you are, it gives you a good disconnection from that threat, and you can do a lot of damage with that. And again, that's just basic cybersecurity sanitation, which no one has a playbook for in the drone world, because a lot of drone operators and pilots are coming up with these applications and just getting others to put them in place. And internal and external storage is just one of those other things. The moment you start flying a drone, whether commercial or independent, you're going to have multiple data points where that is being cached and located. And so in one case, you were basically able to find footage of the internal of the HQ, almost like someone had walked through their whole secure area with a camera, taking footage of everything from sticky notes to just whatever's around. And then because they lost the drone, it's like losing a camera and throwing it in a bush and just having that all sitting there. So this is a company that had a really good standard operating procedure for actually securing their systems, usually encryption and baseline controls. But when it comes to drones, they seem to forget which department looks after drones. So it's like, let's get an innovative area or a department that focuses on drones. Who looks after it? Is it IT? Is it physical security? Is it just the innovation guys? There really is a bit of middle ground that they're forgetting to look after there. And of course, one of the last ones was a drone light show, which are getting more and more impressive. They're able to do awesome patterns in the sky and not have the pollution and environmental impacts of something like fireworks. But just a simple issue with not even securing that Wi-Fi meant that either indirectly or directly, there was no forensics to prove what it was in the end. Multiple of these drones fell out of the sky during the show, and a bit of an investigation went on to try and determine what went wrong. And these are shows that cost upwards of $400,000, right? They're a lot more costly than fireworks sometimes at this point in time. And so by not doing a risk analysis, they would probably apply the same risk analysis that they did to a fireworks show, not realizing that there's actually little computers that are flying in the air compared to just fireworks. So we're finding a lack of simulation as to utilizing drones in these areas as well. So in terms of attack vectors, you can look at individual drones, but one of the things we keep looking at in more depth is these UTM systems, Universal Traffic Management, where they are controlling multiple drones, sometimes from different vendors and makes and models and companies. And so they're really opting for this whole always on type thing, where you've got these drones mid-air connected to the internet, really accessible. And so I'm probably taking a guess here, and I've said it before, but pretty sure it won't be too long until we see, you can hop in and type a drone name into Shodan and suddenly see a drone midair, maybe connect to its camera and see what it's doing and everything inside it. Who knows? But from what we've seen in terms of some of these developers, unfortunately, it is heading to that direction, just like CCTV and a lot of things we see on Shodan anyway. So one of the threat vectors here, and I'll talk a little bit about what we're doing on to create a framework of this, is mass assignment of drones. So previously, you could hit a server or gain access to a server, and that's it. You get rewarded based on that. But now you simply realize that there's a pivot into a drone application or server, which can mean you can control all these different drones at the same time. And some of them really are that easy to be able to manipulate. So you could do some pretty crazy things with that. And these aren't just blue sky thoughts. These are things that they're actually looking at in depth, because they're putting millions of dollars into these smart cities being able to utilize delivery and navigational drones and things like that. One system, for example, has instant no-fly zones that pop up if there's, say, a fire or an airplane in the area that was unannounced. And suddenly it means no drones can fly there, and it applies to all the drones in the area. So if you're able to pop up, create one of those in a very quick manner, or spoof that in a way, then you've suddenly got a bunch of drones that can't return to their base stations or go too high or too low and things like that. So that's more on the, I guess, the cybersecurity side of things, and why we look at some of these measures includes the risk of people using drones for bad itself. So basically, in the height of ISIS in Syria, there was the heavy use of drones to drop little mortars, even just 500 or 600 grams from small drones, onto trucks like this one, utilizing, that were carrying a bunch of explosive supplies, and they would just attach small things like badminton shuttlecocks to the mortars to allow them to drop safely. And usually they wouldn't make too much of an impact being so small, but you drop it on something that is carrying explosives and it makes a much bigger explosion. But the reason why drones are so useful is because it means the operators are disconnected from the threat. So usually if they were using an RPG, they'd be in close range, they'd see where the shot came from, and they'd return fire. In this case, drones just mean they can't even track that operator down unless they have SDR equipment that could actually find where that source was coming from. And the innovation of drones in Syria and war zones has been incredible. This is a video from, or a photo, should I say, from an ISIS drone training class where they're actually teaching them how to modify the drones to continue to carry heavier and heavier payloads. They would strap different batteries to the size of them to use more batteries, and range extenders, but also different ways to try and counter the measures that the US Army were trying to install in preventing against these drones. And the US Army once put out a document entirely on counter unmanned aircraft system techniques, because they needed ways to even tell troops how to run and what pattern to get away from drones and things like that. And one of the important parts of that document says that both reconnaissance and attack capabilities have matured to a point where UAS represent a significant threat to the army. And if they observed over your position, you're already compromised, because that live stream has already gone back to the operator. So units must attempt to engage and destroy a UAS, meaning any organic means available. And they didn't necessarily mean organic in this sense, but what I can tell you is that General David Perkins, and I highly advise you to go look this up on YouTube, once testified that they had a small $600 Amazon drone that was above them and had seen their position and wouldn't go, and small arms fire wasn't taking it down. So instead, they launched a $4 million Patriot missile at the drone. And they go on to say that it did take down the drone successfully, But the big problem was that it was not a great economic ratio, $4 million compared to 600. And he goes on to say that if they had simply sent a swarm of drones to their location, that very likely they could have used up their Patriot missiles, or even worse, made a dent in that monetary side of things. So they take it quite seriously. And it doesn't just take a drone with an explosive payload to cause a lot of issues. As the Met Police in the UK discovered with one drone, basically for 3 harrowing a days, or sightings of the drone meant that they couldn't take off and land. And there's a very good reason for this. Drones are made out of plastic and metal parts. They have LiPo batteries in them which could explode. And if they hit an aircraft, they're much different, apologies in advance, to birds or soft animals. They cause a lot of damage. And studies have constantly shown, drones in an engine of a plane will cause a heck of a lot of damage. So a good friend and journalist of mine, David Hambling, once actually called drones giant mechanical geese from hell. So there is an innovative side to them, but they can also be used for a bit of bad. And one scenario I find really interesting is the fact that some protesters caught onto the idea that a single drone sighting could stop an airport from functioning. And then they realized that not just a sighting, but an alleged sighting could stop an airport, because if there's a drone in the area, they have to stop the planes. And so they ended up just threatening to give an alleged drone sighting to the airport to add more objectives to their protest, and to try and get what they wanted. That's how powerful simply having a sighting without a confirmation can be at airports these days, which we'll come back to in terms of spoofing drones that are in the area, and systems picking those up could shut down an airport without confirmation or proof, because that process hasn't been clearly outlined yet. So I'm going to introduce you into one of the main pillars of drone security, which is the counter drones area. And there is a cybersecurity element to this. And there's also a red teaming aspect to disabling these and getting around counter drone systems. But Jacob Tavis puts out a really easy to understand paper called Drone Defense is Still Illegal, based on the fact that in many countries, other than police and military, you can't use many of these systems. And he explains it in the sense of jam, fry, brick, hack, spoof, grab. And the reason why there are so many different counter-drone systems is simply because the laws are different. So in some countries, they might allow you to jam, and others, they might allow you to spoof, but they won't allow you to hack. But also the innovation, because drones are made out of computer systems, but also electronic components. They have SDR and RF, and then they also have physical aspects to them, the fact that they're flying around in the air, and can be stopped by physical measures. So many different people have created their own functioning ways to stop drones the way they best think. So there's a few countermeasures today that can be best summed up between these categories. The first is geofences. Honestly, probably not the best defense you want to have when you want to stop drones from going to a certain area. They use geofences or GPS coordinates built into the drones to stop them entering into a certain area. And you have to kind of be a big, expensive drone manufacturer to actually install these. Probably getting onto that list is similar to trying to redact your house from Google Earth, and they can be very easily removed by modding. In fact, there's an entire bug bounty system around modding these drones and creating a mod for them. And then, these places will buy them off you and share them with their communities. So geofences don't work too well. And I would go as far as to say they're probably not going to be used too much in the future. You also have radio frequency and GPS jamming. GPS jamming is probably only legal in 1 or 2 countries, such as Saudi Arabia. They're okay with it in a lot of the times. There was a Chinese pig farm that was using a GPS jamming gun to try and stop drones from scaring their pigs and dropping swine flu laden payloads into their farms, and they actually disrupted some of the GPS signals of planes flying over low-hanging planes. So it can be really damaging, hence why you can't even build a GPS jamming system here in Australia. You have to import it elsewhere or export it elsewhere. And some of these systems include things like EMP jammers on the military side, when they just want a force protection immediate stop of drones. They don't care about the laws and how they do it. And then you have other things like the drone guns, which basically jam on known frequencies such as 2.4 gigahertz and 5.8 gigahertz, and extending that where they can, or learn about different libraries of new drones. Most of these are pretty directional. They could interfere with other things in the area and render GPS inoperable. And if you're jamming that connection, some drones will fall out of the sky and hurt things below, which you may not want. And other drones may end up simply hovering there. And obviously, this doesn't necessarily help you actually find the person behind it because you've jammed that communication protocol behind the operator. You also have some of the cybersecurity measures, which is more on the spoofing, hacking, and bricking side. And these are the guys that are reverse engineers, SDR engineers, and they work on creating protocol manipulation weaknesses or spoofing what the controller is trying to tell to the drone to try and disrupt the drone, or in this case, most of the time trying to make it land, which is known as a finesse mitigation. And that's because if they have a drone that has a payload such as a bomb or something explosive, they can quite easily force it to land in a way that doesn't let it blow up. There's a few laws you could disrupt as well in terms of cybercrime acts. It is a hovering laptop, so you're breaking into someone's computer and interfering with communications devices. So it's probably not the best way to do things, but there is some examples of Australian companies even doing this type of thing. And then you have the kinetic measures. These are directional. They use an immediate force, and they have things like capturing drones with nets or shooting them out of the sky with a shotgun. Or even just grabbing them out of the sky with an eagle, which was back in a few years ago. The Netherlands police tried to use this method because the eagle's talons were quite tough. Unfortunately, it doesn't really help when you have a swarm of drones. But the key thing with physical measures is that these are force protection. These are when you don't care about the forensics sitting on inside that drone or trying to find out who is behind it, things like that. So the counter drone industry is in a bit of an interesting place because they're having to deal with CASA, ACMA, the laws, all these types of things that come into having a computer with aeronautics flying close proximity to people as well as up with planes in the air. So regulations are going nuts trying to control this and to figure out how to achieve that. So one of the key things we look at in terms of a counter drone system is people will first ask, am I allowed to have one? Should I get one? Where's the evidence? How many drone attacks are there really? Is it actually a problem? We don't see it in the news. And so that's where one of the key things is collecting all of the incidents that could possibly happen. So this is threat intelligence where it's actionable to an area or to a customer. And you start looking at all the patterns of a certain drone attack. Can you link that drone back to a certain individual, or can you link it back to a group of people? Is it happening again? Were they using the same type of drone? Was it the same communications frequencies in play? Directional patterns. And putting this all together means you can start trying to answer questions about the drones in the air without having to result in counter drones, or actually informing them and saying, yes, you need a hacking system to take care of these drones, or you need a physical system to take care of these autonomous drones which don't use the same frequencies and things like that. So it can probably be best explained like in Singapore. I was actually in Singapore during the air show when the COVID-19 was really hitting bad, and Singapore undertook this significant investigation on trying to find out where a patient had been and link them back to who they had seen, which cars they had been in, which door handles they had touched, which places they had stayed at, called contact tracing. And it was a really good effort, and it meant that they could then predict who might be there next and try and prevent who might go there next to stop them from getting it as well. And so it's an incredible way of doing intelligence, and a similar type thing happens with drone threat intelligence because you're dealing with rogue actors as well, but you're dealing with indicators of compromise and trying to put them all together. So what we look at is if you can take individual sightings, link that with police reports, link that with places that have had attacks, link that to videos or forums online, take all this together and try and link it back to actually apprehending an offender. Now, we are of the view that drones should be innovative and have less restrictions on the industry. We are hobbyists at heart, and obviously we want to see drones continue to innovate. So what would be the point in trying to apprehend some of these? Well, we're looking at the big players, the ones who are flying their drones and filming critical infrastructure, national defense areas, big players that aren't just these little, in terms of trying to be a sheriff and trying to get a drone that has gone into the wrong area. So by doing threat intelligence, you can really start to refine your systems and look at helping counter-drone systems actually detect and apprehend those offenders. I don't have too much time, so I'm just going to quickly cover some of the drone forensics. Imagine in a world where you could take down a rogue drone that you saw, and you were able to do those forensics on it. A lot of the time, it's a hard question between police and the operators themselves, because no one knows who looks after that drone department. But you're in luck, because a lot of drones are very much information heavy. Just like hovering S3 buckets, you can find a lot of information. And the key thing is that you should enact your traditional incident response in a way, with a focus on drones. Because if it's a good drone, you want to know, was it actually, spoofed or hacked into or bricked, or did it just hit a bird or something like that? And if it's a bad drone, you want to immediately start answering that who, what, where, how, why, and how. And with new commercial drones, there are so many data points. You've got the storage components, the applications, the software devices, the hardware devices, the controllers, the vendor servers, where all that information is flying between. And so trying to get a hold of that is a jurisdiction nightmare, especially if it was someone with a drone that was carrying a malicious payload. And in terms of your caveats, what you're trying to work with as an incident responder, if someone is using a custom drone, just like, say, custom malware, then you may not be dealing with your traditional communication protocols, your storage, your different ways of capturing that information. So you need to think around that. And I know I'm short on time, so I'll quickly skip through this. But if you're interested in that, first of all, the Interpol Drone Forensic Responders Guide is a really great guide to get into drone forensics. The other one was the NIST drone dataset, and this is where a company took their drones and flew them around in a field as a baseline, all the same way, over 70 different drones, and gave you an exact chip off of all the forensic components you might come across, even if you're sticking into your traditional IR tools as a cybersecurity responder. So their main thing was, there's a lot of drones flying around, and if one lands and you're asked to do forensics on it, whether it's your own organization or as law enforcement, that one drone, just like if you're operating on a server or a system, you want to take a freeze copy of that, and you don't want to have to try and work on that evidence. So by having these data sets, you can go through and actually find out what kind of file systems and things you're going to come across in the drone, how it works, and what to expect, so that you can do that analysis very quickly. And the timing with drones, just like traditional incident response, is really important, especially if you're trying to get to that physical location where the operator may have been. So drone security has just exploded in the past few years. In the last 8 months alone, we have seen law enforcement from around the world just trying to get in touch to be like, what do we do in this case? What do we do in that case? How do we track this person, and so forth? And there's a lot of issues with the drone security industry at the moment, similar to the internet in its early days. But one of the key things is the lack of people coming in from cybersecurity because they see it as an IoT or a separate type of industry. And currently there are hiring positions for software-defined radio experts, reverse engineers, red teamers to test counter-drone systems, and even drone pilots, coupled with threat intelligence specialists to try and put that all together and match it. Because we're just dealing with computers in the sky that have the physical ability to really hurt or do some damage. And so it really is becoming its own section. And so one of the key things we've been working on is different frameworks for the drone industry. The threat intelligence we focus on tries to catalog all the incidents and allow people to try and detect and predict where things might happen. But one of the key things that we've been doing is creating a MITRE attack framework for unmanned systems. So this is where, just like your ICS framework with MITRE, it shows you how an attacker might take pivoted or lateral steps through a system. We want to be able to look at all the attack methodologies that occur to drones, from the controller all the way to the drone, to the servers, to the UTM servers, including counter-drone systems, and basically be able to take that all into context and help people who are creating these systems to put little milestones and checkpoints on where they would do incident response, or where they would put that secure architecture design in to prevent attacks like this. And it's a huge field. We are looking at SDR and RF based attacks. You've got physical attacks, you've got cybersecurity based things, and hardware based attacks as well that you're all looking at. But that's something that we've been working on for a while. We're going to continue to try and sharpen and hopefully release with MITRE for unmanned systems that are different to IoT. The other one is a counter drone self-assessment framework. So like I was saying, with counter drone systems being similar to antivirus, it's no good when they do their own results and publish those themselves. You want to be slightly agnostic or independent. So almost like some of those companies that take all the drones at the same time, all the antivirus at the same time and compare them. We want government agencies and organizations to do that themselves, completely independent. So creating a rating system that you can provide, very much like disclose.io, thanks Casey, where it's an assessment of that, not being shilled by maybe the company who's trying to sell their product, but getting something that's right for your environment, getting something that's right for the types of drones they're seeing, and being able to be handled by the right team in your department. Is it the security guys? Is it the IT guys? Is it physical security and so forth? So that's basically it in a nutshell. I can go into depth in any of these topics if you want to talk to me on a specific basis, but I just want you to take some key things away from this, and that's that drones are continuing to be a huge cybersecurity problem. And to really understand the whole section around it, you have to understand, there's counter UAS, there's laws and regulations which prohibit a lot of these angles. There's new areas like threat intel and DFIR, which is only being applied to drones now. So it's almost like starting from zero. And the drone industry really needs frameworks like OWASP and SD Essential 8 and NIST, things like that to really guide it. But that's kind of it in a nutshell. So thank you so much. There are some resources that might be able to help you, and there is a bit of a silent push there for our threat intel platform, which is something that we're happy to work with people on, but we do try and get a good idea of all those different drones in the area. And if you have any questions, just ask on the questions part of the Slack. So thank you very much. Thanks for waiting up. And I think I'm the last talk, so if I am, have an awesome night, and appreciate it from the ComfyCon team.
There are a lot of mute buttons to get through before I'm back on air. I think Ian's in the same boat.
I've done it again, haven't I? I've done it again. No, thank you very much, Mike. That was a good talk to end with day one of ComfyCon. I think there's a lot of interest in terms of drone security and how it works with all other aspects of security as well. So thank you very much for that.
Pleasure. Thank you so much for hosting this.
No worries.